In first place, I would like to thank you for the interest you have shown in this video tutorial. HCC-Hotel Cost Control, with myself as a lead man, has the main principle of providing theoretical models in order to better the management in the lodging and hospitality industry, training users to have at their hand practical management tools at a low cost, as it avoids knowledge exclusivity and makes them public and accessible to everybody. It has to be mentioned that these theoretical models only come to light once they have been put into use in the industry, and once reviewed, the relation between the cost of its implementation, measured by the time dedicated, and the result obtained, measured by the evolution of key management ratios of each area. Regarding beverage management based on the HCC model, I have worked on this device for the past 10 years, in hotels worldwide and with a combination of different board bases. Therefore, its effectiveness has been trialed in any possible assumption. It has always obtained better results in all cases, which has been from 8 to 20%. If you press attention to the elaboration of this management and control report of the Beverage Department, surely you will have immediate benefits in the economical results of your organization, and also in the level of detailed information obtained, which will allow you to focus on any deviation with total preciseness and correct it. With view to the implementation of the model, an important comment is ought to be mentioned, which is that it is retroactive. Therefore, not only does it work as from the date of the implementation, but you can also make consultations on available data from past periods, which is useful to establish corrective measures if there are constant deviations in time. On another hand, once the implementation has taken place, its maintenance consists on only create new entries for the new articles, to which you dedicate no more than 30 seconds on the POS or point-of-sale software and in the stockroom software. The update of sale and cost prices continue as normal in your IT system, and this adaptation uses those changes to generate new tracking reports. Therefore, there is only need for one implementation per article, independently for the modification of units sold or consumed as to the variation in cost and sale price. Without further ado, we start with the video tutorial. This course divides itself in 6 modules or chapters, in which the necessary information is present for a successful implementation. We will start with a short introduction to the current situation of beverage management and control, and also its peculiarities and its limitations when having to control deviations. Secondly, I will explain how to configure the database table in the point-of-sale terminals, to be able to group sale articles which share only one stockroom consumption article. Thirdly, I will explain how to configure the database table in the stockroom, in order to be able to convert beverage consumption articles into portion for client service. Once analyzed these entries, we will go on to establish a relation between the POS and the stockroom of each department, in order to be able to carry out an analysis of results and control deviations. The Beverage Control Report will allow us to know with great detail the return we will obtain from the beverage sales of paying customers, what cost we incur with our invitations and on the house consumptions, and also how much does an all-inclusive guest really consumes, if applies. The last module consists on the application of the BCG Model, abbreviation for the Boston Consulting Group, based on historical results, in order to establish a precise sale price policy based on the demand of our clients and the cost of each article. Module 1. Introduction. Nowadays, and in general, the calculation of beverage costs comes from obtaining the sales from the POS or point of sale of the department and valuing towards itself the corresponding amount of on-the-house consumptions or invitations. On the other hand, we obtain from the stockroom of this department the amount which corresponds to the beverage consumption, from which we discount the invitations part according to the POS data. A fixed cost percentage is applied on the volume of production of the said invitations. In our case, we apply 20%, but that depends on each company. The remaining beverage consumption, which is equivalent to the total consumption minus the invitations, that is, the consumption from the paying customers, is divided amongst the sales to the said paying clients, obtaining a percentage of reference which is equivalent to the charged cost per each beverage sale article. In the case of hotels which offer all-inclusive board buses as well as other board buses, for which they share articles of service, for example, a soft drink is a sale article as also included in the all-inclusive buses, the general calculation system is to apply a fixed cost to the volume of sales provided by the POS, which is discounted from the total beverage consumption, leaving the rest of the consumption as of the all-inclusive guests. Dividing the said consumption amongst the clients with drinks included, we obtain a value which corresponds to the cost that the said client incurs per day in concept of beverage consumption. This system normally takes place because, although in some cases it is established to register the all-inclusive beverage services in the POS, although they are no sales articles, the final result normally doesn't coincide much with what has really been served. This happens because the staff don't normally register the drinks when served, but they accumulate services to register them when there is a minute of tranquility in one ticket in general in the POS, incurring that not everything is registered or that they register in excess, which invalidate the usefulness of this procedure and the data that it generates. We will see it more simple with a practical scenario for each case. In an ordinary hotel with no all-inclusive, we have net sales which amount to 1,600, and the POS indicates that the sale price of the invitations amounts to 680. On the other hand, the stockroom informs us that the total beverage consumption is 595, as we discount from this the corresponding on-the-house consumption, 20% of the estimate of the invitations, which is 680. So we are left with 459 beverage consumption destined to sales. Dividing the consumption amongst the net sales, we obtain the beverage cost per unit sold of 28.7%. In a mixed hotel, in which all-inclusive board buses is offered combined with other buses of payment, the composition of the calculation will be as follows. We have net sales, which amount to 1,600, and value the invitations as 680. As indicated in the general introduction, we are not going to take into account the value of all-inclusive services which the POS reports, as this data is of uncertain credibility. The stockroom informs us that the total beverage consumption is 860, and that after having taken away the invitation consumption, that is the 20% of 680, as the consumption of paying customers, that is the 20% out of the 1,600 net sales, it calculates a beverage consumption destined to all-inclusive clients of 404. If we were to have 300 clients in all-inclusive, the cost per client will be 1.34 per day. On the other hand, the cost of beverage sales to paying clients will logically be 20%, as it is the variable we use to discount from stockroom the beverage of paying customers according to the volume of sales. In the last scenario, the hotel is 100% all-inclusive. In this case, we analyze a hotel with 0 sales, in which the on-the-house consumption are assumed by the all-inclusive clients, as in general, there are no POS to register the services, as they are all included. Therefore, if the stockroom indicates that there has been a beverage consumption of 404, this total consumption will be divided by the 300 in-house clients in all-inclusive, giving as a result the 1.34 that the all-inclusive cost us per day in this point of sale. Once the calculation system has been established, the only option left for the management to manage the beverage department is to take as a reference a fixed beverage cost, in our case the example of 20%, and comparing it with the obtained result. In the scenario that the obtained result is much higher than the expected, an alarm arises and we detect that something is failing in the beverage consumption, but we cannot establish what articles are the ones that generate the deviation. We only know that something is going wrong. It has to be known that this system is very disputable, as due to its peculiarities when it comes to beverage costs, a constant ratio does not exist, as it depends on the demand of the articles of each period. We establish the analysis of 2 beverage articles as an example. On the one hand, we have a bottle of water. We sell it at 1.80 and it costs us 0.30. Therefore, its cost is 16.67% on the sales of this article. On the other hand, we have the house wine, which we sell at 10.30 and its cost is 3.40. Resultant cost is 33.01%. Now, let's imagine 2 periods in the year that, due to the demand of our clients, the sales of both articles alter. As it can be observed, in period 1 the cost is of 25.38% with 28 and 60 sales, whereas the second period the cost is 32.45% with 106.60 in sales. If we are to follow our control strategy, we will think that in period 2 there has been deviations and that something is wrong in the department. But in reality, there has only been a change in the demand of clients and it has benefited the company. There is no deviations, as all that has been sold has been consumed. Therefore, the procedure has been correct. It has only been the behavior of clients which has changed. Module 2. POS – Configuration of the table of articles. We enter in the process of adapting our POS database table in order to be able to carry out the implementation of the HCC model for the beverage management and control. In the first table, which is gray color, we have the information that we obtain from any POS, independently of the software we have contracted. The report indicates the POS to be analyzed, in this case it's the bar, the beverage subfamily, and the articles in each subfamilies. Each of the mentioned groups has always got assigned a specific code number. In the report's detail, we observe 6 articles, 2 draught cokes in 25 and 50 centiliter formats, individually bottle of coke, individual bottled water, and 2 types of draught beer, one in 25 centiliters and the other one in 50 centiliters. The POS itself indicates the units which have been registered as sales, as also the ones assigned for on the house consumption, invites and other courtesies, not all inclusive. Finally, The report calculates the sales made per articles by paying customers. Its sum will give us the total amount of beverage sales which have been generated in that point of sale during the period. An important notice: all data in this video tutorial are free of taxes. That is, there are the net sales from the department once the VAT or the pertinent tax applicable has been discounted. Steps to follow for the implementation of the HCC model. The modification in order to adapt your current system to the HCC-Beverage Management and Control model consists in adding 3 manual fields into the database table. The first is a related code that will put into groups all those sale articles that share a cost article. The second field is a common name, which we are going to assign to each shared code so we can identify it in the resulting report. For example, we can take the 2 types of Coke and the 2 types of beer. In each case, they have in common the Coke's bag-in-box or premix and the beer's barrel. This is, no matter if we sell 25 or 50 centiliters Coke, this is always consumed from the bag-in-box or the premix or another modality used in each case. On another hand, no matter if we sell a pint or half a pint of beer, both articles will be served from the same barrel. And finally, the third field is the converter. This field is used to put all the related articles into only on sales format, with the aim of associating it to only one stockroom's cost format. As an example, we have decided to create a related article for the 50 centiliter size Coke. Therefore, the converter to change the 25 centiliter size Coke article is 0.5. For every 2 sales of 25 centiliters Coke, we convert it into the sale of one 50 centiliters related Coke. For the 50 centiliters Coke article, the converter factor will be 1. If we multiply the 610 units served of 50 centiliters Coke by its converter, this will tell us that we have served 610 convert units. When the system generates a comparative report, it will tell us that we have served a total of 770 50 centiliters convert Coke units, which is the equivalent to 320 25 centiliters convert Coke, that is 160 50 centiliters Coke, plus the 610 50 centiliters Coke from the POS article number 32. The same happens with the rest of the articles. The variables of related units on the house unit, sales unit, and related sales price are automatic calculations. We don't need to generate further fields. The first 3 are the result of applying the multiplication of the converter field by the result given by the own POS. In the case of the related sales price, the formula to be applied is the division of the POS sales price amongst the converter in each case. Module 3. Stockroom. Configuration of the table of articles. Following the module's pattern, in this case we find the report generated by the Stockroom's module. In the mentioned, we can observe the lookup Stockroom's name, which is the equivalent to the bar, the family, and the detail of purchase article with its corresponding codification. The report indicates the unit measure of each article, the unitary cost in relation to that unit measure, the consumption of units, and finally, the amount of that consumption for each article. Let's see again an example of articles that are used to give coverage to a same sales article. For example, in the Coke's case, we have two backing box formats, one of 5 liter and another one of 15 liter. In the beer's case, we have barrels with capacities of 25 and 50 liters. For the bottled water and Coke, we only have one article which is associated to only one sale article. Steps to follow for the implementation of the HCC model. In this case, we have to add 4 manual fields, although 2 of them have been created previously. Let's over them. We have a code and a related name article, which is the same one used in the POS database table, and that needs to be assigned to each purchase article as pertinent. The third field is the return, and in order to configure it, we need to check with the supplier how much product is extracted from each article. Take the following examples. Article 328, Coke backing box 5 liters. According to the supplier, for each liter of syrup, we extract 6.2 liters of the final product by adding 5.2 liters of water to the syrup. Therefore, the return will be the calculation of multiplying the format of each backing box article by the 6.2 multiplying factor, so that for the Coke backing box 5 liter article we establish that we obtain a return of 31.5 liters, whilst for the backing box of 15 liters we obtain 94.5 liters of the final product. For each bottle Coke, and as the measured unit is the bottle itself and not the 25 unit box, the return will be 1. That is, each consumed bottle will equate to 1 bottle as final product. We have the same scenario with the bottled water. And with the beer barrel, the supplier informs us that we generate a 9% decrease per barrel. Therefore, we obtain 22.5 liters of final product from the 25 liters barrel, whereas we obtain 45 liters of final product from the 50 liters barrel. This may be the field we ought to invest more time with, and the one we need to pay more attention to, as there are many formats of purchase articles and they are very differentiated. They all are calculated in different ways in order to obtain the final product quantity which it reports. We go on to the portion, which consists of converting the return into a comparative unit against the POS1. It will be more clear with the explanation of the following chart. If we know that we obtain 31.5 liters final product from the backing box Coke, and we have established that the related article will be measured by 50 centiliter units, we will have to use the portion variable in order to equate the units measured. In the case of the related Coke 50 centiliters, the portion will be 2, which is the result from multiplying that quantity times the returned liters, converting them into sales servings. This is, by multiplying every Coke's returned liter times this portion, we will know that we obtain 2 Coke servings per sale. In the case of the bottled Coke and water, for each return of the final product per its portion, we obtain the same number of servings per service, or, what is the same, there is a related sale for each bottle of water or Coke consumed. With the beer, it happens the same that with the Coke, as the return per liter of final product we have calculated, and the sell products are counted in 50 centiliters. Therefore, for each returned liter we have a portion of 2. The values of the fields portion consumption and portion cost are automatic calculations, based on the information obtained from the very same stockroom model. Analyzing the portion consumption of the Coke's bag-in-box 5 liter, we obtain the following calculations. We have consumed 9.12 Coke bag-in-box 5 liters. We know that for each bag-in-box we obtain a return of 31.5 liters of the final product. 5 liter bag-in-box times 6.2 return according to the supplier. So, multiplying the consumption of units of the bag-in-box 5 liter, that is the 9.12, times the return of each bag-in-box, that is the 31.5 liters, we obtain the consumption of the final product at 287.22 liters. We ought to multiply this result times the portion factor, that is 2, with which we obtain a consumption service 2 of 574.56 servings of Coke 50 centiliters to final clients. The cost of the portion will be the result of dividing the consumption cost according to the stockroom, 193.62, amongst the consumed portion, the 574.56 converted units, giving us a result of 0.34 per serving of 50 centiliters consumed. This example is to be applied to the rest of articles. Module 4. Establishment of the relation POS-Stockroom. We go on to establish the relation between POS and stockroom for each department. Firstly, we will analyze a hotel that does not offer the option of all-inclusive. That is, all articles served are for paying customers, as also for invites on the house or other courtesies. It has to be mentioned that this process is completely automatic, and it is generated from the field related article code, which we have configured in the 2 previous models. The report is composed of the following sections. Unit control, POS and stockroom. On the one hand, we need to ask the system to inform us of, for each related article and for the period being analyzed, the units registered on the POS, classed as on the house, sales of paying customers, and the sum of the sale, taking into account that these values have already been converted into a common unit measure. On the other hand, the system also has to calculate the units consumption in the common variables compared, and we will be able to detect at one glance the existing deviations per article between the POS, or what is served and registered, and the stockroom, or what has been consumed. Deviations in negative indicate we have consumed more articles than what has been registered in the POS. Therefore, we have either committed an error when doing the stock taking, or we have not registered all servings to clients in the system. Theoretical unitary return. This second block allows us to know what will be our optimal cost per article according to the unitary sales price and its cost. The information per article has already been established in the previous models. Therefore, we only need to ask the system to show them. Real return. In this block, we will have to multiply the POS total units served, including the sell units as well as the invites, times the unitary sales price, with which we will complete the POS production field. To calculate the real cost, we need to multiply the stockroom's consumed units times the unitary cost. And finally, we need to calculate the percentage of the real cost obtained, dividing the real cost obtained amongst the real production. We understand as production the sales we have made plus the value of the invites. Deviation. Here we continue with the calculation process. The deviation percentage is the difference between the percentage theoretical cost and the percentage real cost obtained. The economical value is the result of multiplying against the POS real production the said deviation percentage obtained. That way we can quantify how much each deviation costs us. Logically, we need to elaborate a totalizer line in order to value as a whole the economical deviation of the period. It is advisable to establish a filter system to consult this report. As in the example, we are analyzing only 4 articles, but imagine when you have 150 articles on sale and not all of them have a deviation. It will be a loss of time to analyze each article. This filter should only be shown in those articles that have a difference lower than 0 in the units on POS and stockroom, or what is the same, the articles that have more consumption than the units that have been registered on the POS. There will also appear articles with a difference higher than 0 between the POS and the stockroom, which indicates that there has been an error when doing the stock taking, as it is not possible to serve more units than what has been consumed. And what happens with the hotel that have all-inclusive mixed with the rest of board passes? Well, as we have pointed out previously, we cannot trust the units registered on the POS under the concept of services of clients in all-inclusive, as it fails in 90% of the cases. Therefore, we establish an automatic adjusting system for this field. And how do we do it? So we assign the value of unit difference to the field all-inclusive unit. That way, we adjust the unit registered in the POS to the ones consumed in the stockroom. But we need to take into account that not all articles that we offer in a point of sale are articles included for all-inclusive clients. Therefore, the adjustment only has to be carried out on those articles shared between the paying customers and the all-inclusive ones. In the example, we have regularized the Coke 50 centiliters and beer 50 centiliter units, as they are articles which are served to paying customers and to all-inclusive guests. But the deviation in the bottled Coke and water persists, as they are articles which are not included in the all-inclusive beverage offer, and therefore should not be regularized if they have deviation, as these are directly related to the paying customers. We continue with the next module, in which we establish the control system of deviation in the scenarios in which there are clients in all-inclusive. And what happens in the hotels that only offer all-inclusive but do not have POS? The HCC model will only be configured in the stockroom module, but if the rest of procedures are carried out, it will be possible to obtain a report like this one, in which the units of each article consumed by all-inclusive customers are detailed, being able to identify tendencies and adjusting the offer and stock availability according to the customer's demand, optimizing the stockroom's management. We will attempt to copy in the POS section the information provided by the stockroom, always leaving at 0 the difference between units served and consumed. Module 5. Creation of the Beverage Control Report. This fifth module brings to an end the beverage management and control cycle, which bases its calculation in historical data, as it cannot be analyzed until a stock taking is carried out and the stockroom is regularized, obtaining the cost of the beverage consumptions. The aim is to compose a report of simple results based on the table of relations of the previous model we have reviewed, which indicates at a glance if there are deviations we ought to analyze and, if that is the case, be able to read its detail using the POS and Stockrooms relation report we have seen before. The outline is simple. We break down the clients into three groups: paying customers, all-inclusive, and on the house, and we establish the following fields to be analyzed. By type of clients, which has to be obtained from the front office module or to be introduced manually. In the paying clients group and all-inclusive, the value doesn't arise much debate, as it corresponds to the in-house guests according to their board passes. For the on-the-house group, it is advisable to add the total guest in-house, independently of their board passes, as it will indicate what cost we add to each accommodated guest according to our invites and on-the-house policy. Sales or production. For paying customers will be the net sales registered, whereas for all-inclusive customers and invites, it will be the economical valuation of the articles served. Consumption. It is calculated based on the units served to each group of clients by the unitary cost of the said. Consumed articles. It is the result of dividing the number of clients of each type between the registered units of each of them. Here we have an indicator to establish in hotels with all-inclusive, as it makes no sense that an average client in that board basis consumes more than 4 or 5 articles a day. Sales or production per client. It is the result of dividing the sale or production per client group between clients per type. Here we see another indication on all-inclusive clients, which will tell us if there is an excess and therefore a deviation. Consumption per client. In this case, we calculate the real cost incurred by all-inclusive client. Percentage cost on sales. It is a good indicator to assess the return obtained from the paying customers group, who are the ones that generate business in the point of sale. Deviation and valuation. Data to analyze at a glance the beverage management in the department and in the period of time. For those hotels with no all-inclusive, the figures will only appear in the paying customer and on the house columns, whereas in those hotels with all-inclusive only, there will only be figures in the columns clients per type, number of articles consumed per client per day, and consumption per client per day. Final note of this section. As all-inclusive is the result of adjusting articles which are shared amongst these board passes and paying customers, all deviation generated will be visible in the variables of articles per all-inclusive client, production per all-inclusive client, and consumption per all-inclusive client. Therefore, these deviations have as explanation an incorrect stock taking of the shared articles or not registered correctly in the POS the articles which correspond to paying customers, which are automatically assumed by clients in all-inclusive. Module 6. Applying the BCG Model. The BCG matrix, abbreviation which stands for the Boston Consulting Group, of strategical character for companies and organizations, has been used in the hospitality industry to develop what is known as menus engineering. Basically, the classification of articles in a menu according to this discipline divide themselves in star, profitable and in demand, horse, profitable and not in demand, puzzle, not profitable and in demand, and dog, not profitable and not in demand. It is widely used in the renovation of menus in restaurant and at food and beverage levels. In our case, we use the matrix version according to three variables on the one hand and the strategy to follow by each company on the other hand. This way, in first place, we collect historical data from paying customer sales in a specific period of time showing related article to be analyzed, sold units, impact of each article over the total articles sold, unitary sales price, unitary cost, and percentage cost. In second place, we outline the newest scenario which takes into account on the one hand the cost variation of each article for the new period, and on the other hand the percentage cost that will represent in function of the sales price that we decide to apply, which is the manual calculation we ought to do. In the example, we have calculated that the supplier will increase 6% in average. The third block corresponds to the application of the BCG to our model. Taking as variables demand, we establish what level we consider suitable to differentiate the articles that are successful to the ones that are not. In the example, we class that articles with a demand higher than 12% are to be considered successful, marked with an X. Sales price increase. We establish what level we consider critical to review new prices, and from it we will take actions in each case. In the example, we set condition a price increase higher than 7% over the current sale price, marked with an X. Cost. We establish what level we consider suitable to, in function of the new cost of each articles, to set a new sale price. For example, we will differentiate between the articles with a cost higher to 8.8%, marked with an X. Taking into account the structure we have set and the formulas established, we are going to start to propose sale price per article so that, in each case, they follow the guidelines established according to our company policy. This example shows that the management has established that the demand rules. Therefore, everything that is over, that is, all successful articles, will have a price increase lower than 7%. Meanwhile, all other articles will have to increase their price until the cost places itself under the critical level established. With these guidelines, we see that both the Coke 50 centiliters and the beer 50 centiliters increase their price in 6%, as they are the most in demand, whereas the bottled Coke and water increase their price more than 7%, reaching a cost lower than 8.8%. This criteria is normally very conservative, that is, the price of the most demanded articles increase very little, with the aim of warranting their sale in the future, and punish the articles with less demand so they at least have an optimal return. In worst of cases, it is understood that clients that consume the articles with less demand have the option to change to the star articles, in the event that the price of the aid is considered as excessive. In the event of losing this client, at least the sales of star products remains the same. In the following example, the company's guidelines are completely opposite. Basically, they want to increase the price of the articles most in demand over 7% and also secure that its cost is maintained lower than 8.8%. On the other hand, will review prices of the article less in demand by lowering them independently of the cost obtained of the sale. This criteria is more aggressive and its aim is to adapt the client's demand of the establishment, rolling out all available articles and not restricting it to the star articles. In the worst scenario, it is assumed that the client that consumes the article most in demand have the option of changing to the ones with less demand, which are generally more exotic or normally are left to expire in the rack. And although a percentage of clients may stop consuming the star articles in the bar, the final result will be the same as the price increase has been considerable and have improved the margin in each star product. I wouldn't that this video tutorial comes to an end before adding the reasons why this model is not suitable for the food group, and I don't put it forth due to the following reasons. It doesn't normally respect the ingredients in the price tag with the offered in the final product, as it takes advantage of ingredients that change throughout the season. For example, a change in the garnishing will put an end to the model. The elaboration of the model is too complex, and taking into account the previous point, not very precise. Nevertheless, it can be applied to certain articles of the food family that do not suffer transformation, like crisps, ice creams, sweets, and ready-made meals which are ready for its serving. For this, the system is identical and equally precise, and taking into account that they can represent a high percentage in the food consumption of certain points of sale, it is a good idea to have them under control as well. Finally, I only wish that this video tutorial has been clear and satisfactory. Likewise, I hope that you will soon put it into practice, and wish it will report you great satisfaction and allow you to control with greater precision this business area, as it has done with me throughout my practical experience. Kind regards, and don't forget to consult our training program for new video tutorials or online courses by subscribing to our newsletter in order to be updated on all our innovations.